Welcome back. This video aims to be an extension of the previous video. In the previous part, we looked at how we can composite still background plates with VFX elements. So that was working with still images, which means no time dependency. Now, there isn't too much complication when it comes to time dependency. There's maybe one setting that we need to change, but as a workflow, I thought I would take you through it and also dive deeper into the background plate node so that you can take it apart and use the elements that you need from it. So let's begin by taking a look at our footage. So I simply have this over here, and it has been decomposed into individual JPEG frames. It is a 25 frame per second video clip. This was just taken from Pexels. You can go over there to find all sorts of great footage to practice your camera tracking and VFX elements with. And so this is all that I have. Now, this has already been camera tracked in another piece of software. And out of it, I have a camera track, as well as some of the placeholder objects, such as a street and the facades of the building. So to import that, which is usually going to be our first step, we'll go to import. So file import. Usually you will get it as a Filmbox FBX or an Alembic. So we can go ahead and choose Alembic, street video track. And over here, I know it is 25 frames per second, and the start frame is actually frame 0. As for the type of geometry that we would like to load, we will load Houdini geometry, and then we can import. When it's imported, you'll see this Alembic archive, and you'll see that it has frame set to 0 - 1. That's simply because we set our starting frame to 0. As for the frames per second, this has not changed, and that's because it actually fetches our global setting for our FPS. To change this, we go to the bottom left and change the FPS to 25. We then apply that FPS and just make sure that that is accurate to your footage, or else you'll end up with timescale issues. For example, if you have a shot that is playing back in real time at 60 frames per second, and it is 60 frames, that's only 1 second of footage. So 60 frames relates to 1 second in real life. If you were to play it back at 30 frames per second, then you would end up with 2 seconds of footage and half the speed. So your playback rate is halved. That means that if you do anything like a simulation, it will look really odd because it'll be assuming that 30 frames is 1 second, whereas in your video, 60 frames is 1 second. So just take note of your frames per second when working like this. Now we can take a look and you'll see that we have a camera that has been brought in and a few points of reference. We have our geometry for the wall on the left, our geometry for the wall on the right. We also have a sidewalk, a street, and this person standing here for scale. Now, there are also tracking markers floating about, and all of those things are contained within this Alembic archive. So as you can see, we have a camera here, and that big plane in the background is actually inside of this camera, so we can delete that. We also have the camera trackers, which I'll hide, this random guy, and then we have a bunch of these planes. Now, as you click through them, you'll be able to tell which one is which, and I'm just going to rename them so that I know which one I need to be focused on. So this is going to be our street. This one is going to be our sidewalk. The one on the right is going to be our close wall. And then we can just delete everything else or just hide it because I have a higher resolution piece of geometry that I would like to bring in for the left wall. Okay, so that's all we really need. Let's go up a level and drop a geometry node. This geometry node is going to be used for all of our light blockers. So these are going to be for our holdouts. So we can call this holdouts. Dive inside, object merge. With this object merge, we're just going to select the things that we want to bring in. That's going to be our close wall, our sidewalk, and our street. So we'll choose each one. And because these are actually Alembic objects, we need to put /**. That brings in everything that's inside. And we also want it transformed into this object. So apply all the transforms when bringing it in. As you can see, we now have this side wall, and then we can do the rest for the others. So let's just add the rest of our objects. We also want our street. So that's going to be street down here. /**, and then the last one, sidewalk, /**. Cool. Now, as for the facade on the left-hand side, I'm going to use a file node to bring that in because I have it as an OBJ. So building facade.obj. Merge these two together. And now the only thing that I want to add to this, because oftentimes you will end up with a situation where only a few pieces of geometry are relevant, but then you'll end up with these gaps. Now, all of these gaps in our geometry are fine for now, but when we actually start working on this, light can leak through in these areas. For example, in real life, there would be no gap over here for light to come through. But because we don't have an enclosed space, light can come through and affect our VFX elements. So to fix this, we can simply do a bound. And of course, there are other ways to do this. A lot of them, perhaps even better methods than this. This is a very basic approach. I'm just going to give it some padding on every axis, then use a blast node and simply blast this front face and the top face, just like that. I'm then going to reverse it so that the faces are pointing in, and then merge that back with the rest of our geometry. So it just gives us this. right? So now we don't have any light leaking in from any places where we don't want it to. Once we have that, let's drop a null, and these are going to be our holdout objects. And just one thing that I glossed over when initially recording, do be sure to just add a normal node after your merge, because what you may find is that your shadows are pointing in odd directions or are not being cast correctly. And that's simply because of the normals of the holdout objects. All of these things which catch shadows need to actually have normals on them so that the shadows can be calculated correctly. So right over here, just a normal node will fix any of those issues. That's just something to keep note of. I did initially forget this in the tutorial, so I'm just coming back to reiterate this. From here, we can go to the stage level and do what we've done before. So that'll be a SOP import, and these will be our holdout objects. Load in what we just created. Let's import our camera. So that's going to be a scene import cameras, and we now have access to our camera in our viewport. Let's drop a calmer physical sky. I know that the light is coming from the top right, more or less, and I've experimented with this a little bit. So I found that a solar altitude of about 55 and an azimuth of about 60 is close enough for now. The only other thing I'm going to do is increase the angular size so we have slightly softer shadows, and then increase the turbidity slightly. There we go. So if we take a look at a CPU render, that's all we have. All right, so some light being cast over there, and we can increase the exposure on this to 1.5, and that looks a bit more accurate. Now, we want to feed this into a background plate lob so that we can begin adding elements into our scene. So we're going to drop a background plate, plugging this into our background plate. Over here, we need to choose which primitives to use. That's going to be our holdout objects. And then the plate that we want is going to be that image sequence. So street video, and we just choose that image sequence. Now we won't see anything until we drop a comma node. So comma, plug both of these in, and there you have it. Now you will see this weird thing where the sky looks a bit odd, and that's simply because our comma physical sky is rendering the light geometry. Disable that, and that will correct itself. The only other thing is on the comma render settings on the image output, we want to import our render vars from second input. Okay, the last two things that we're going to do is just select our camera. So that is the correct camera that we want to be using, as well as the resolution of our sequence, which is going to be HD. Now, this is actually important because I have found that sometimes when we use the slap comp a bit later, it crashes if we don't have the correct camera setup and we don't have the correct resolution. So do double check this if you do find that your slap comp is crashing every time you try to activate it in your viewport. It's just something that I discovered, and for some reason that seems to fix it. Okay, now let's go ahead and integrate something into the scene so that we can check if this is working correctly. Let's go ahead and drop a geo node. We can call this test object, and inside of it we'll drop a sphere. So just a sphere, and I'm going to ghost other objects so that I can see where it is positioned, move it about, and increase its size, something like that. Okay, that will do just fine for what we're trying to test. Back to our stage level, SOP import, test object. SOP path, go ahead and find it, bring it in. So there we have our sphere just being brought into our scene. Now, one thing that you may notice is this, where it appears pink. Now, this is something that occurs because of our background plate node, and it generally occurs when we have time dependency. So if you take a look at your plate, we have this $F, so there is a time dependency. This orange that we're seeing is a missing texture, and the reason it occurs is because our background plate node fetches all of the objects, our holdout objects, and projects our background plate onto it so that it can reflect it back onto our objects in our scene. So when it doesn't have a texture to find, it reflects back this pink color. And I can actually show you exactly what that is doing. If we just use a material linker, let's just make our sphere something like chrome. So we have our test object, and I'm going to grab a chrome material and just throw it onto our test object. As you can see, that is what it's reflecting. It's reflecting this weird pink. Now to correct that, we can very easily just allow shader parameter animation, and that will correct that issue. You will also see that there is this black area being reflected, and that is our off-screen texture. You can use an off-screen texture and then select one, but this is anything that falls outside of the range of what can be projected. As for your off-screen color, it would help to set this to a color which is similar to the rest of the background. In our case, that's going to be something that's sort of grayish brown, something like that, a little bit darker, just like that. All that's doing for us is just making sure that our reflections and the light that's bouncing back is based off of something a bit more realistic. As for our calmer physical sky, you can also see that reflected in the sphere, but basically that's all we really need to focus on. And all of that is particularly important if we're working with things like glass or metallics, because if we just put a glass material, you can see that it needs to reflect something, right? And so when we have objects like this in our scene, it is important to make sure that we do have our background plate being projected correctly onto our holdout elements. Now, this is going to cause a slight issue when we move forward, and I'm going to show you what that issue is. Of course, we want to be doing a slap comp. So if we drop a comp network and just call this slap comp, you'll become aware of the issue very shortly. When we go over here and do a slap comp block, so slap comp block, it brings in our previous render, right? As you can see, we have our render and that's all well and good. We can add our AOVs and everything is working as it should, except we now have our background plate in our actual render. This means that we can't do any compositing over here because it has already been added to our render. The way that we have to fix this is by actually diving inside of the background plate node. And this is where it becomes relevant to understand how this node actually works. And now you may, of course, be tempted to just remove the plate, right? If we remove the plate, then we no longer have that issue and we now have a sphere and we can now comp everything back in using a file node as we did in the previous part. The issue is we now no longer have anything reflecting back on our sphere. So we want to maintain this relationship between our sphere and the projected holdout texture, but we don't want it to be rendered. So how can we change that? Well, if we allow editing of contents, we can dive inside of this background plate node. On the left-hand side, you'll see everything that it is doing for the holdout objects. If you click over here, you can see that this is running over our holdout objects. So that's a reference to whatever we've put up here. Now, the only setting that you really need to change here is going to be in your render settings down here. If we scroll down under the Karma tab, you will find that it is saying use background auto. If we set this to off, it'll no longer use the background as an image to render. Now, if we take a look at it, we only have our sphere and we've maintained the relationship to the plate, right? So we still have our plate active, but it's no longer being rendered so that when we go to our slap comp, you still have your sphere. And that means that we can now just bring in a file and do all of the things that we've done before, as well as anything with our shadows. So there we go, just an invert on our shadows, a multiply with our plate, and then bring in that back together. So now if we view this through our viewport, we can enable our slap comp and it works as expected. It's no longer relying on this background plate. So now that puts us in a good place to use our slap comp to do all of our compositing, with our background plate only being used to project this texture and to generate our AOVs. So now, while we're on the topic of this background plate node, let's take a look at some of the things that it's actually doing for us. On the left-hand side is everything that will be applied to our holdout objects. Everything on the right is AOV generation, things like your shadows and your diffuse, emission, all of that. Now on the left-hand side, an important thing to note is this render geometry settings for our plate. You can see that it's running over our holdout objects, and what it's doing is it's setting the holdout mode to background. The only thing that you really need to understand about the difference between background and matte is the way that the shadows are generated. So background assumes that we have a plate and we want to drop our shadows onto it based on our VFX elements. When we have a matte is going to be more like a blocker. So it's an object in the scene, but we're not rendering it, right? So if we go back to this level and take a look at our holdout shadows, this is when it is set to background. It's applying these shadows, treating the objects as a background. When we set this to matte, you'll see that this seems mostly the same. It does appear slightly darker, but when we take a look at our holdout shadows, it's actually got all of the shadows in our scene. Now, this just means that background is going to be the most useful for the background plate node, but there will be times where you want to block something with a matte. So do keep in mind that you can always change the render geometry settings of any geometry to be a background or a matte. That is just something that you can do. As for this material library, if we dive inside, it looks complicated, but the only thing that we really need to focus on is that it's grabbing our background plate and applying it as an MTLX image as the base color of a Material X standard surface. That just means that we're projecting this image onto all of the geometry coming into this material library. As for the render settings, we already looked at this. This is simply using the background. You can choose to have it render or not render, and this is something that you can also change after the fact. We have the render settings node as well as the render geometry settings node. And between these two, you'll find all of the settings that you need. So over here, under the Karma settings, if you scroll down on your render settings node, under the image settings, you will find this use background option. We can set or create it over here. So let's just go back to our camera view, right? So over here, it's now affecting that. So we can always make this change outside of our background plate blob. And that is exactly how. You'll just use this use background. And if you actually want to render your background plate to disk, this is how you do it. you switch this to on, and then you don't have to do all of the compositing steps, but obviously then you have less control. So that's just one thing to keep in mind. Now, as for these things on the right-hand side, inside of our background plate node, these are all of our render variables. If we go through each one of them, you'll see that they're all the same node, but the only difference is in what each one of them is generating. So as you can see, we have a data type and a source name, and then down here, a name for the actual AOV. This is what you see in that dropdown. So when we're looking here, this Holdout Shadows is this over here. You can rename this to something else, like Holdout Shadows Custom. If we go up a level, you'll see it right here, Holdout Shadows Custom. This just means that we can make our own AOVs. Now keep in mind, it does get a little bit complicated because we're using LPE, or light path expressions, and these over here you can find information about on the RenderMan website. Some of it is somewhat intuitive based on the names. For example, holdouts are going to be these things that we've created here in our plate settings. Shadow is just going to be the shadows that are being cast. CDL is color diffuse for all lights, as far as I understand. I may be wrong about that. But you can see that each one of these is slightly different. And this is useful to know because if you need custom AOVs for whatever reason, then you can make your own. And you can make them using this render var node. So render var or additional render vars. So this one right here. And this one comes with some presets as well. And we've used this before. Right, so if we were to add something like holdout, you'll see a very familiar looking thing over there called holdout. And if we go to our render view, we can now see that we have this thing called holdout. And there's various things that you can do. For example, this is going to give you just your glossy reflections. And of course, this has many, many options that you can go through. And this is also a good way to learn how these source names work. Okay, so now that we have full control over all of our settings, we can actually go about adding things to our scene and making it feel a bit more rich and full of our very own elements. And so to do that, I'm going to start bringing some elements into our scene, and I will show you what I've brought in afterwards. All right, so all I've got here is a cone. So this is a traffic cone that I've created right over here. The only thing of note is that it does have an attribute called roughness because I want the base to be more rough than the cone. And so we're going to use that in our shader. Other than that, I have this flag. It has been time offset, so it's the same simulation. Each one has just been time offset so that they don't match. It has been split up using a name attribute into the pole and the flag, and we have UVs on it. So we can apply an image to this and have that image on our flag. Then there is this hole, and this is more complicated than the rest. The general idea is that I have a vellum grain simulation, and I have created this using an RBD material fracture. Then using a shape match, you can keep these certain pieces together, use a vellum glue, and then pin everything that is outside of a particular simulation area. You just end up with this. And another thing that I did over on the left-hand side is this UV projection. So if you convert particles to a VDB and then to a geometry, you can use a UV texture node to project from the camera view. So as you can see, I've time shifted this to frame 144. When you reach frame 144, this lines up with your camera view. Now, you can also use it where you don't time shift this, but it's not entirely necessary. What we do then is just transfer the UVs onto these points and then transfer it onto the deformed points using an attribute copy so that each point gets the correct UVs. Convert that, then transfer it onto the geometry. All this is doing is it's taking those UVs that were on our static points and it has applied it to our deformed geometry. Using a UV smooth, I just smooth off the UVs slightly. And what this does for us is it gives us a street surface with UVs that are projected from the camera view. So we can actually apply our background plate as a texture and it'll get the details of the street from our actual street imagery. I've just merged this in with some light blockers underneath so that no light leaks through and save that out to disk. Okay, that's all. And so once you have that, it's very easy to add things into our scene. As we know, we already have this test object. We can easily remove that and just add our own objects. I'm going to run through this fairly quickly. We have a SOP import. We can call this cone_1, grabbing that cone. Let's go to our camera view, merge our cone in with everything else. And then let's add a transform node so that we can move this cone around. I'm going to go back in my timeline. I can see my cone sitting over there. We can move it around. If you want to view this as a render, you can do that. Right, so once we enable our slap comp, we can see our cone in our scene, hiding a couple of these things. We now have access to our transform. You can see that if we move it over there, it should show up in the light. If we move it back over the side, it's back in shadow. So now simply we just want more of these cones. So let's add a merge, and we'll duplicate the cones and the transform over so that we have 2 more. Plug that into the merge, and now we just have these 3 cones very easily set up over here. Okay, so we have our cones, but they don't have a material. Let's give them a material. We can use the quick surface material. This is a new node in 20.5. Right over here, give it a name. We can call it cone material. We're not going to change too much. We're going to go over to the specularity. We're going to push up the roughness to 1 because it acts as a multiplier when we use an attribute for this. So you will see that we have a roughness primvar, and that's just the name of the attribute that we created. So roughness. The only thing is we need to assign this material. So use an assign material node. What we want to apply it to is /cone, but not just cone1. We want all of them. So asterisk cone underscore asterisk. And then the material path is just going to be /materials cone material. There we go. You can, of course, add things like displacement or a normal map, whatever you want. I'm going to leave them fairly simple because this is just an example scene. Let's put that into a network box and go ahead and add our flags. So once again, SOP import, this time just bringing in our flags. So we have flag 1, 2, and 3. These are all separate. So flag underscore 1. These are going to need transforms as well. So we can drop a transform node, merge this in as well. Take a look at our scene, and let's position our flags. So I want it moved up against this wall. Let's preview it with our comp, and we can see that it should be moved over a bit. Perhaps a bit higher would make sense as well. Something like that. And then let's once again duplicate this over and merge it together. So we'll do 3 flags, and this time we won't just be renaming them, but we'll actually be bringing in different flags. So that's going to be flag 2 and flag 3, and let's make sure we're importing flag 2 and 3. So flag 2 and flag 3, and then adjust the transforms. There we go. So we have our flags in our scene. Once again, we can create a quick material for them. So quick surface material, plugging it in after this merge. This is going to be our flag material, and we will also have a pole material. So we can duplicate this and make one called pole material. The flag material we'll keep very simple. We'll just give it a color map. So I'll choose this logo flag, and that is just the Houdini logo. We can increase the specularity slightly. Over on the pole material, we'll make it metallic. So increase metalness to 1, give it a sort of brass color, decrease the specularity a bit, and then we can use an assign material to assign our materials. So we want to assign this to our flag, but we don't want it just for flag 1, we want it for all of our flags. So we'll replace the number with an asterisk. As for the material path, simply put in the material name, flag material. When you do that, you will now see that we have our Houdini logo showing up on all of our flags. We can then add another material, do the same thing for our poles. So that's going to be flag underscore asterisk / pole material materials pole material. There we have it. And if we go ahead and render, this should work perfectly fine. There we go. The last thing that we'll add is the hole that we created. So that's going to need a SOP import. With the SOP import, we will call this hole, finding it right over here, street hole. Merge that in as well. And this is where you may notice a slight issue, and that is that the hole is being blocked by our street. And you may think that, okay, our street doesn't actually render, but remember it does act as a matte. So it does block light, meaning that we won't get any ray bounces coming back because it is considered a blocker. So when we go to our CPU view, you will see that the hole only sticks through in certain areas. The way that I found to fix this, and there's plenty of different ways, you can even just do this as a compositing trick, but all I'm going to do is actually brute force it and cut a hole out of our street. So let's just go over to our holdouts. Over here, we just have all of our geometry set up. I'm going to object merge in that hole so that I can see it for reference. So quite simply, I'm going to draw a curve around the area that I want to cut out, extrude it down, use a Boolean, and that will allow us to cut this out. The one thing that I do want you to take note of is that these objects that we're bringing in, some of them are poly soups. So to actually get that as regular geometry, we can just use a convert node. So we can plug it in right over here. And as you can see, no more polygon soup. Now let's go ahead and use a draw curve. Draw curve is just a useful node for drawing shapes onto a geometry. We'll use this as first input so that we can use it as a projection. So switching your projection to geometry, we can now draw on our geometry. With our display flag on the object merge for the hole, let's click on the draw curve, then on the transform handle, and now we can clearly see it and we can just draw around it. So we'll draw around, and it doesn't have to be perfectly accurate or anything. The main intention is simply to have an area to cut out of our street. And it's also all right if they aren't connected. Just try to make sure that each line starts fairly close to the other, because all we'll need to do now is, once we have our curve, fuse it together. Once we've done the fuse, we can use a polypath. So polypath, and then go ahead and use a poly extrude, extruding this down. So we won't be using the distance, but we will be using transform extruded front set to global and then pushed down. We will also move the entire thing up slightly, because if we take a look at our street, you can see that it's perfectly level with it. So we'll just move it up slightly using our transform node. Something like that is fine. And now we just need a Boolean to cut this out of our street. So we'll take our convert, that'll go into first input. Second input, we'll take our Boolean, and that may look correct, but we don't actually want it to be doing this where it solidifies the interior edges. So treat the input A as a surface. That'll make two cutouts, and that works perfectly fine. And now we'll take that and use that as our holdout object. And that's what we now have. So we have an area cut out for our hole. If we go up to the stage level, you can now see that we can quite clearly see the area where our hole is supposed to show through. If we go to a CPU render, there it is, right? So it's been cut out of our street. The only thing that's left is to give it a material. I'm not going to go too in depth with it. It's just going to be a fairly straightforward material. You can, of course, do the texture projection that I spoke about because we do have UVs on that, but I'm just going to do a quick surface material just to keep this straightforward. This is going to be our street surface, and then we can assign that as a material, assigning it to the hole and the material path / materials / street surface. We can also apply this to just the surface of the hole. So street surface, that works as well. And now with the street surface, let's just change our color. So the color that we want to be matching is going to be the street color in the light, right? So this is the shadowed area that is in light. So we want it close to that color. And so we'll just firstly decrease our specularity, increase our roughness, then go ahead and choose a color. It's going to be close to gray, but slightly brown. So we'll do this reddish brown, closer to yellow, desaturate it a bit more. There we go. I'm not going to be too fussy with it. We basically just want it to fit into our scene, and I think it's doing that quite nicely. The only thing that we may want to do is just go into our slap comp, and over here, just ensure that we only have the relevant connections for our render. So we're bringing in only the C and the holdout shadows. If we need holdout reflections, we bring that in too. Then we do our block begin, our compositing, and we simply have our block end. Of course, we can do all sorts of compositing in here, as we saw in the previous part, but I've kept it simple so that we can focus on other things in this tutorial. So if you want to render that to disk, go to your USD render op at the bottom, scroll down to Husk, over to slap comp, add a slap comp, set it to a cop network, and the cop node is simply going to be your slap comp block end. Once you have that, you can render to disk, and then you will end up with a sequence that looks like this. So I hope that you enjoyed this tutorial. I hope that you learned something from it, and I hope that you enjoyed the series as a whole. Whether you did or you didn't, feel free to leave a comment so that I can get some feedback from you. All feedback is appreciated. Thank you for spending this time with me and for watching these videos. I'll see you with the next series coming soon. Until then, bye.